AMC 2019 examination, AMC 10A, question 19 was to find the minimum value of x plus 1 into x plus 2 into x plus 3 into x plus 4 plus 2019. Well, if you want to find the minimum value of this whole expression, essentially what you need to do is to find the minimum value of this uh, of x plus 4 into x plus 3 into x plus 2 into x plus 1 and add the result to 2019 to get the answer. So let's just write that down here. F of x is going to be equal to x plus 1 into x plus 2 into x plus 3 divided by x plus 4. To get some intuition into this function and how will we actually find the minimum value, let's actually try to graph this function. Now, the AMC exam will not allow you to use any type of graphing calculator or any calculator. And so, therefore, you will need to kind of visualize the function on a two-dimensional piece of paper. And by doing first, you will actually, you can notice from looking at this function that there are four roots to the equation, and the roots are -1, -2, -3, and -4, which is fairly easy to see. So let's just write down these four values down at the x-axis. I'll just label the axis here. So the graph of the function will actually pass through these 4 points. Now, let's actually try to see the values of f of x when x is greater than -1, that is on this side of the graph, and the value of the function when x is less than -4 for values of x that are here at the left hand side of -4. At the right hand side of -1, f of x will always take positive values. This is because all of these values, x plus 1, x plus 2, and x plus 3, x plus 4, they will all be positive. Therefore, the value of f of x will always be positive after -1. So, the value of the function will always be above the x-axis and it will continuously be increasing. It will be increasing because it is a degree 4 polynomial. Just completing it in a nice way. That is done. And for values of x less than -4, you also notice that the f of x always lies above the x-axis for values of x less than -4. This is because this for values of x less than -4, this is going to be negative, this is going to be negative, this is going to be negative, and this is going to be negative. A negative number multiplied by a negative number multiplied by a negative number multiplied by a negative number gives you a positive number. This is because this is a positive number and this is a positive number. Understood? So the function will also be kind of like the same shape on that side, on the other side of -4. But what will be the graph of the function for values of x between for in the range -1 to -4? How will the function actually look like? Well, we know that since the graph passes through all of these 4 points and it passes through, let's just start from -1 and -2. Let's try to visualize the function from -1 and -2. So we know that it passes through both the points. So since the function is continuous, there has to be a stationary point between these two, between -1 and -2, and it goes around here. The function cannot just come right here and then go straight towards that. It is a continuous function. It has to approach some stationary value, then go back here. Similarly, the same thing will happen for values of x between -2 and -3, and for values of x between -3 and -4. So what we did is I'm just going to change the color of the pen here. So we noticed that from simple analysis of this question, we saw that there are actually two values at which f of x can take a minimum. We just don't know which of these are the answers because we haven't computed them yet. We will do so in a short period of time. So excuse me. The f of x is at a minimum at either this point or at this point or at both. F of x could be a minimum at both of these points as well. We don't know yet. But we certainly know that for values of x between -2 and -3, f of x is also always positive. Because, yeah, we can see that this is positive. So the minimum will either occur for x between -1, -2, for -3 and -4, or either both. Now let's try to solve this question. So the approach that I used here was to actually see the stationary values and to compute them. But the problem is that to compute the stationary values, I would have to differentiate this function. So I would have to find, uh, yeah, I would have to find f dash x. I will have to differentiate f of x, and differentiating f of x will give me a cubic polynomial. F of x is right now a quartic polynomial. So let me just write that down. F of x is a quartic polynomial because it is a degree 4 polynomial. F dash x will be a cubic polynomial, and to find the stationary values, I would have to solve that cubic polynomial when it is equated to 0. So I will have to solve this equation and find its roots. I will get three roots. As I can see from this graph, there are three stationary values, and two of them or one of them would give me the minimum value. The value of x at which the minimum occurs. Yeah, but you notice that this is quite a long method because first you have to expand this, or you can just use the product rule, but then you would have to differentiate it, and then you would have to solve the cubic equation, and solving a cubic equation is not easy, especially with this case when you can see that the answers to this cubic equation are not integers, they are decimals, as they lie between values of integers, -1 and -2, -2 and -3, -3 and -4 in this case. So we can just see that solving this cubic equation won't be the best option. There's got to be a better option than this. So we will see how that better method could actually save us a lot of time. And note that this AMC exam is just for 75 minutes, and there are 25 questions on this test. So for a question like this, so a question of this difficulty, you should take about 4 to 5 minutes to solve it, or even less, depending upon how the level of the other questions. Now let us see the other method which we could use to solve it. Let's say before starting, I would like to give you some intuition as to how we will approach that method. Let's say there is a function ax squared plus bx plus c. This is a quadratic function. And if I tell you to find the minimum value, you could easily do so because finding the minimum value of a quadratic function does not require a lot of work. You just complete the square, or you can just take the value x equal to minus b over 2a, substitute it into this equation, and get the corresponding value of y. And if a is positive, then the value will be a minimum. If a is negative, it will be a maximum, because in this case the shape of the function will be an upward, it will be an upward parabola, and this will be a downward parabola. So the point will be a minimum, the point will be a maximum. So this is like just a recap of quadratic equations, and finding the minimum of a quadratic equation is extremely easy. But so the kind of strategy we will use here is to convert this equation into a quadratic equation. So this equation, how can this equation be converted into a quadratic equation in the first place? Well, to get some intuition, I'll be showing you an example. So the example which I'm using is I'm writing it on the screen. Let's say I give you another function. Let's call it g of x is equal to ax to the power 4 plus bx to the power c, bx squared plus c. This kind of does look like a quadratic equation, but the problem is that it is still a quartic polynomial. It still has a power 4 in it. The degree is 4. It's not a quadratic expression. But you could actually convert it into a quadratic expression by actually turning it from a function of x to another function. Let's say the name of the function is h. Let me just write it down clearly. So instead of g, we could actually, instead of a function of x, we could convert it into a function of another variable. Let's call that variable u, and that function will be a quadratic function. But how? We will take u to be x squared. So if u is x squared, this function will be au squared plus bu plus c. And once we can get, and if we know the values of a, b, and c, we can easily find the minimum of h of u. We can find the minimum or the maximum, depending upon the sign of a, if we know the values of a, b, and c. if we know a, b, and c. And if we find the minimum value of this function, since this function is actually equal to this function, we'll just find the minimum value of this function as well. And we can find the value at which this occurs by using the formula u is equal to x squared as we used before, as we just substituted this into this equation. So we'll be using this exactly the same approach in this equation, but by using a different method. So let's start. F of x, I'm just going to use a different color because I've been using the same color throughout. I like to change my colors. So I'm going to use probably a purple color. Yeah. So f of x is x plus 1 into x plus 2 into x plus 3 into x plus 4. And what I do is, in order to convert it into a quadratic, I club these two terms together. So it becomes x plus 1 into x plus 4, and I put a bracket around it so that I can separate it, and I club the remaining two terms together in the same way. Excuse me for the bad handwriting. I got this Wacom tablet recently, so I need some more practice, but I'm sure you can understand it. Anyways, so I have clubbed these two bracket terms together. Now I just need to expand them. So this bracket becomes x plus 1 into x plus 4 is actually x squared plus 5x plus 4. And this is x squared plus 5x plus 6, right? Notice that here we x squared plus 5x is a common term. And notice that these are constants. These values do not have x in them. They are just 4 and 6. And this is x squared plus 5x. So what does this mean? We can express f of x as another function, let's say h, of u, where u is x squared plus 5x. So h of u will be u plus 4, where u is x squared plus 5x, into u plus 6, the same thing. Notice that I've converted this f of x into h of u, which where h of u is a quadratic expression. So this is 24 u plus. So this was not just out of the blue. First, I just rearranged f of x, and the purpose of doing that was to make this term common. So what I did was I looked at this expression and saw that 4 plus 1 equals 5 and 2 plus 3 also equals 5. So I knew that x squared plus 5x is got to be common in these two terms. So I combined them together to get this expression. And now I can easily find the minimum of h of u. So the minimum of h of u is, and notice that it's a minimum because the coefficient of u square is 1 and it will be an upward facing parabola. So the minimum will be if I just plug in minus b over 2a, minus b over 2a will be minus 10 over 2, which is minus 5. And if I plug that in into this equation, I'll get minus 5 square plus 10 into minus 5 plus 24. And this will give me 25 minus 50 plus 24, which will give me minus 1. So minus 1 is the minimum value of h of u and is indeed the minimum value of f of x. So, tada, got the answer, yay. So let me just erase the, I hope you got the working because I'm erasing it now. Yeah, so minus 1 is the minimum of f of x. But notice the question was to find the minimum value of x plus of this function of f of x plus 2019. So the answer will not be minus 1 but minus 1 plus 2019, which is 2018. So this is our answer. Now the value of, now you might be asking, what is the value of x at which the function is minimized? We actually did not find the value of x, we found the value of u at which the answer occurred. Remember, the function was h of u was u square plus 10u plus 24, and the value of u at which this occurs will be minus 5 minus b over 2a. So this means, and u was x squared plus 5x. So we can just solve this equation. Therefore, we get x squared plus 5x plus 5 is going to be 0. So you can solve it using the quadratic formula, because factoring it will be quite difficult, impossible. So minus 5 plus minus square root of b square minus 4 is c, which will be 25 minus 20 upon 2, which was gonna be equal to minus 5 plus minus root 5 square root of 5 over 2. So this will be, so so we will have two solutions for this. One will be minus 5 plus square root of 5 over 2. The second one will be this minus root 5 over 2. So let me highlight these equations and erase remaining stuff. And if you put these values into a calculator, which you are not allowed, but I'm just doing it for the sake of this video. If you plug this in into the calculator, you'll find that this value is minus 1.38, and this value is, it's a non-terminating decimal, it's an irrational value because I have a root 5 right here, and this will be minus 3.61, blah blah blah. And notice that I had said that the function can take a minimum at both of these as well. And that's indeed the case. It takes a minimum at minus 1.38, and it also takes a minimum at minus 3.61. So there you have it. I actually proved, and I actually showed you that the answer was 2018, and that's all that was required for the AMC exam. But I extended it to show you that the values of x at which that occurred was actually these two values of x by solving the equation for u. So that's it. Thank you for watching, and I hope that you learned about some new problem solving strategies. And just remember that whenever you try to maximize or minimize a function, apart from differentiating the function, try to convert it into a quadratic when it is possible. It's a really useful trick. Thank you.